Let's read the question. Consider the conversion of O3 into O2 as 2O3 gives 3O2. O3 gives O2 plus O. This is a fast reaction. Then O3 when adds with O gives 2O2. This is a slow reaction. The overall order for the conversion is. Students, in this question we are given with a complex reaction. And for complex reaction we need to know that the overall order of the reaction depends upon the slowest step, that is a rate determining step. So here we can calculate rate. Rate is equals to K, that is rate constant, and then the concentration of reactant. So concentration of O3 and concentration of O. Now student, we need to calculate the value of concentration of O from the first equation, that is the equilibrium reaction. So here we can calculate K equilibrium is equals to concentration of product upon concentration of reactant. So concentration of product is O2 and O, and concentration of reactant is concentration of O3. From here we can calculate the value of concentration of O. So concentration of O is equals to K equilibrium multiplied by concentration of O3 upon concentration of O2. Now let's put the value of concentration of O in the rate expression. So rate becomes K concentration of O3 multiplied by K equilibrium multiplied by concentration of O3 upon concentration of O2. Now students, let's take this K and make it K dash, and then concentration of O3 whole square, concentration of O2 raised to the power minus 1. Since the overall order is the sum of the powers of the reactants in the rate law expression, which is equals to 2 plus minus 1, which is ultimately equals to 1. That means the overall order for the conversion of 2O3 to 3O2 is 1. So the answer is option 1. Moving to next question, students, which is question number 82. Let's read the question. The weight of copper, atomic mass 63.5 U, displaced as Cu2 positive ions by a quantity of electricity which displaces 11200, that is 11,200 ml of H2 at STP will be. Student, here we have to calculate the weight of copper that is displaced by the same amount of electricity which displaces this quantity of ml of H2 at STP. So let's see which formula is used. As we all know that for this question, the equivalent of copper must be equal to the equivalent of H2 since same amount of electricity is used. So is W upon E of copper is equals to volume of H2 at STP in ml upon 11200. So we can calculate W as equivalent weight is 63.5 upon n factor, and for n, and the n factor is 2. 11200 upon 11200, that means W is equals to 31.75 gram. So the correct answer for this question is option number 3. Moving to next question, students, which is question number 83. Students, here let's see the question. The reduction potential of hydrogen electrode at 296 Kelvin containing 10 raised to the power minus 5 molar H ion is. Here we are given that the pressure of H2 gas is 1 atm. So student, first of all I'm writing the reaction. This is 2H plus 2 electron gives H2. Now reduction potential of hydrogen is equals to standard reduction potential of hydrogen minus 0.0591 upon n. Here n is 2 log pressure of H2 raised to the power 1 upon concentration of H plus raised to the power 2. Now students, as we all know that the standard reduction potential of hydrogen is 0 minus 0.0591 upon 2. The pressure of hydrogen gas is already given 1. So log 1 upon the concentration of H ion is 10 raised to the power minus 5 whole square. Let's further solve this equation. Minus 0.0591 upon 2. Here log this will become 10 raised to the power minus 10, and when this goes in the numerator it becomes 10 raised to the power 10. So log 10 raised to the power 10 is 10 has a value of 1, which is equals to minus 0.2955 volt. That means the correct answer for this question is option number 2. Moving to next question, students, which is question number 84. Let's read the question, students. The Gibbs energy for the decomposition of Fe3O4 at T Kelvin is as follows. Half Fe3O4 gives 3 by 2 Fe plus O2. And for this reaction, the value of delta G, that is Gibbs energy, is plus X joules per mole. The minimum potential difference required for the electrolytic reduction of Fe3O4 at T Kelvin is. Student, first of all, in this question, we have to calculate the change in oxidation state of Fe. So I'm writing in the reactant, this is half Fe3O4, which further gives 3 by 2 Fe plus O2. Here, the oxidation state will be 8 by 3, and here it will be 0. So change in oxidation state of Fe will be 8 by 3 minus 0 multiplied by 3 by 2, which is ultimately equals to 4. Now students, we know the relation between delta G and potential difference, which is equals to delta G equals NEF. Since the value of N is 4, the value of delta G is X. The value of F is must be taken as F only, because we can see in all the options F is given as F only, and we'll be able to calculate the value of E. E will be delta G upon NF. Delta G is plus X and the value of N is 4F. That means the correct answer for this question is option number 1. Minimum potential difference is equals to X upon 4F volt. So answer is option 1. Moving to next question, students, which is question number 85. Let's read the question. The electrode potential for Cu positive aqueous to Cu solid and Cu2 positive aqueous to Cu solid electrodes are 0.52 volt and 0.34 volt respectively. The electrode potential to Cu positive aqueous electrode will be. Student, here we have to calculate the electrode potential of a cell Cu2 positive to Cu positive. Student, for this question we need to know that E cell is not an additive property. So we have to convert E cell into delta G, as delta G is an additive property, that is Gibbs free energy is an additive property. So first of all, we have to calculate the value of Gibbs free energy for the given two reactions, and then we'll be able to calculate electrode potential of the third reaction. So let's see. First reaction we are given with Cu positive plus 1 electron gives Cu solid. Here it is aqueous, and for this reaction the value of delta E is 0.52. For this reaction the value of electrode potential is 0.52 volt. So delta G is equals to minus NF E cell, which is equals to minus 1 multiplied by F multiplied by 0.52. Now student, let's proceed with the second reaction. Cu2 positive aqueous plus 2 electron gives Cu solid, and for this reaction delta G, let's put this 1, this as 2, this will be minus NF E cell. The value of N is 2, F must be taken as F, and the value of E cell is given as 0.34 volt. The next equation is Cu2 positive, which we have to calculate. Aqueous plus 1 electron gives Cu positive aqueous. This will be delta G 3, which is equals to minus 1, since the value of N is 1, F is taken as F, and we have to calculate the E cell for the reaction. Let's assume this as X volt. Since student, we know that the Gibbs free energy is an additive property. So G3 is equals to D delta G2 minus delta G1. If we subtract the first equation from the second equation, we'll be able to calculate the delta G value for the third equation, and then we'll be able to calculate the electrode potential for the third equation. Since this is minus X into F, this is equals to minus 2 into F into 0.34 volt minus, and minus minus plus, this is 0.52 F. The F is cancelled from all the three terms. So the value of X becomes 0.16 volt. That means the correct answer for this question is option number 4. Moving to next question, students, which is question number 86.